Hello everyone, welcome back to my channel. I am Anushka Srivastav. So this is my fifth lecture in my data science series playlist. So let's see what are the topics that we are going to cover today. Today we are starting model evaluation. So what do we mean by model evaluation? Model evaluation is the process of assessing the performance and effectiveness of a machine learning model using various metrics and techniques. It involves comparing the model's prediction against actual outcome to determine how well the model generalized to unseen data. The goal of model evaluation is to ensure that the model is reliable, accurate, and suitable for making prediction in real-world application. Key components of model evaluation includes number 1 evaluation metrics, number 2 modern evaluation techniques. Model evaluation metrics. Classification metrics used when the target variable is categorical. Common metrics include accuracy, the ratio of correct prediction to the total prediction. Precision, the ratio of true positive to the sum of true positive and false positive. Recall, the ratio of true positive to the sum of true positive and false negative. F1 score, the harmonic mean of precision and recall, balancing both metrics. Confusion matrix, a table that summarizes the performance of a classification model by showing true versus predicted classification. Regression matrix, used when predicting continuous values. Common metrics include number 1 mean absolute error, the average of absolute error between predicted and actual values. Number 2 mean squared error, the average of squared error between predicted and actual values. Root mean squared error, the square root of MSE, providing error in the same units as the target variable. Mean absolute percentage error, the average of absolute percentage error expressed as a percentage. Model evaluation techniques. Number 1, cross-validation. A technique to assess how the result of a statistical analysis will generalize to an independent dataset. K-fold cross-validation. The dataset is divided into K subset and the model is trained and the tested K times, each time using a different subset as the test set. Holdout method. The dataset is split into training and testing sets, typically in a 80-20 ratio to evaluate model performance. Continuous evaluation involves regularly assessing model performance in production using new data to ensure it remains effective over time. Application of model evaluation. How to perform model evaluations using Python. To perform model evaluation in Python, you typically follow these steps. Number 1, data preparation. Split your dataset into training and testing sets using functions like train, test, split. Number 2, model training. Train your model on the training set. Predictions. Use the trained model to make prediction on dataset or test sets. Evaluation metrics. Calculate various evaluation metrics to assess model performance such as accuracy, precision, recall, F1 score, and confusion metrics. Number 5. Cross-validation. Implement cross-validation to ensure the model robustness by evaluating it on multiple subsets of the data. Number 6. Performance analysis. Analyze the result and compare them against baseline models or desired performance level. Number 7. Iteration and improvement. If necessary, refine the model by adjusting hyperparameters, selecting different algorithms, or gathering more data. Step-by-step implementation. Step number 1. Prepare the data. Split the data into training and test sets. Step number 2. Train the model. Create an instance of the model. Train the model. Step number 3. Make prediction. Make prediction on the test set. Step number 4. Evaluate the model. Calculate evaluating matrix. Step number 5. Perform cross-validation. Step number 6. Analyze performance. Compare the evaluation matrix against your baseline or desired performance level. Identify strength and weakness of the model based on the result. Step number 7 is to iterate and improve. If the model performance is not satisfactory, Consider collecting more data, refining features, trying different algorithms, tuning hyperparameters. By following these steps, you can effectively evaluate and improve your machine learning models using Python. Step-by-step guide to implementing unequal error cost. Number 1. Prepare the cost matrix. A cost matrix can be defined where the element at position I, j represent the cost of predicting class I when the true value is j. For example, consider an example of a binary classification problem where a false positive predicting class 1 when the true value is 0 has high cost, whereas a false negative predicting class 0 when the true class is 1 has low cost. Step number 2. Train your model. Train your model as usual, but once you make the prediction, you need to evaluate the model's performance based on the cost matrix. Step number 3. Calculate the cost of errors. To calculate the total cost, you will multiply the confusion matrix with the cost matrix. This gives the total error cost for the model's prediction. Number 4. Optimize the threshold. If you want to further optimize the decision threshold, you can adjust the threshold based on the unequal cost. This means choosing a threshold that minimizes the weighted errors cost rather than just maximizing accuracy. You can consider this example. Step number 5. Adjust model for cost-sensitive learning. Alternatively, for certain models like decision tree, you can integrate the cost directly into a model using class weight or sample weight. For logistic regression or other classifiers, you might modify the class weight to reflect unequal error costs like this, in this manner. So here I am ending my video. I hope all your concepts are clear. I have discussed each and every topic briefly. Thank you. See you in the next video.